Okay, this is going to be a very quick video explanation on how I did the review guide. First of all, this was really basic. This was the experiment we did in class on the simulation. I just graphed the points. I didn't need to make a scale. It was made for me, and I added the title, How Mass and Speed Affect Kinetic Energy. I graphed it. I can see that one graph is much steeper. It is increasing at an increasing rate. So it asks me the question, what increases kinetic energy more, increasing the mass or increasing the speed? Well, this is very obvious, is the red line is my speed line and it increases much higher. And in this case, I was measuring kinetic energy and how far the box was pushed by the cart. Great. Here, draw two free body diagrams, peak contact forces. So, how did I draw it? Here, I said the mass was 20, that's why I wrote 20 in here. I drew a line to show that it was moving at 10. And then don't forget, I drew these lines, I tried to make them identical because anytime there's a collision, the force is going to be equal, okay? So this number doesn't represent the total force, this represents the speed, but my length of my arrows represent that the forces are gonna be equal, okay? Then over here, I have a mass of 10, so I wrote 10 in there, and then 20 kilometers. Now, I did try and still make my lines the same, exactly the same, but I made these ones longer, right? So I made them longer than these ones because I know that increasing the speed has more effect on total kinetic energy, or total peak forces, than the mass was. So the key thing is here, I identified that speed has a bigger impact on total kinetic energy, so I drew my arrows longer, and that for each side, I know that there's an equal and opposite reaction, so that's why I try to draw them identical to each other. So these two should be about the same length, and these two should be about the same length. Going on to the other side, making a graph, it does say make a line of best fit. If it says make a line of best fit, make a line of best fit. If it doesn't, do not. So I chose a scale up to 6 because for me, the scale made sense for about every 1, 2, 3, 4, about every 5 blocks. So 1, 2, 3, 4, 5, 6. Why did I do that? Well, for my independent variable, which goes on the x-axis, the biggest number was 5. On the other side, I made it, this one was much easier, 10, 20, 30, 40, 50, and my biggest number on the other side was 32. Cool, so I just graphed it out. I made a line of best fit, and I had to predict what it would be at 5 kilograms. So, made a line of best fit. Then, I made sure it went through 5. I went up, I made a star. I estimated it to be, I don't know, a little bit under 5. So, I wrote 4. All your answers will be a little different depending on how you estimate the line of best fit. Great. Next, I graphed the data below. This just shows me that the faster something's going, the more the arrow is going to have an effect. So I try to draw both my arrows identical to each other, and I didn't draw them very long because we're not going that fast yet. Then, as we continue, I made them a little bit longer, but I made them equal. Because however the cyclist is hitting the wind is also hitting the cyclist with the same force. And then the last ones, I tried to make the longest to represent that is the most kinetic energy, the highest peak force, but again, I tried to make them the same. So all I did was I graphed it out. I chose my scale of 50. That one, because that was my biggest number. The other side, the top number was 100. My top number was 90, so pretty good scale. I graphed it out. It did not tell me to make a line of best fit, so I didn't make a line of best fit. I just connected the dots. Great. I gave it a title of headwind versus kinetic energy lost. I titled my y-axis as kinetic energy loss. My x-axis is speed of headwind. Wonderful. All right, and it says, if there was kinetic energy or life transferred, what kind of energy did it become? It said the kinetic energy was transferred into thermal energy due, that's a misspell, due to the collision with air particles, which is called friction, and released into the air as heat. I'm even going to add that to make this a 4-point answer, as heat. Great. All right, the next one. If you read about the Hyperloop, what it is they are trying to remove oxygen from a tube so there's less friction, and then we can have a train go through that thing. They also want to use various ways to not have any contact, not have any wheels really, just have it float. Some designs have tried to use Magnets. This design tries to use air, like air hockey. And so I said that the Hyperloop will go faster than a plane because it will minimize friction. It'll achieve this by eliminating the tracks and the wheels and removing air particles from the tube. With less particles making contact, the less friction and the faster it can go.